Today we're going to learn to graph systems of linear equations. Remember, all linear equations will fall under three categories. Those who have one solution because their slopes are different. Those with no solutions because they have the same slope but different y-intercepts causing them to form parallel lines. And the third type is the ones that have infinitely many solutions because they are two lines that are right on top of each other. Remember, all equations you will want to put in slope-intercept form, which is y equals mx plus b. Which is the slope-intercept form, because all you need is a point and the slope of a line, and you can graph any line as long as you have those two things. Here we have y equals 2x plus 1. Since y is already by itself, we have our slope, which is 2, and our y-intercept, which is 1. So we always start with our y-intercept. Our y-intercept is 1. That means we're going to place a dot at 0, 1, which is right here. Make that a little bit bigger. Then we're going to use our slope. Since our slope is 2, that means we have to go 2 up and 1 to the right. Anytime we have a whole number slope, all we have to do is put it over 1. If the slope is positive, we go up and to the right. If the number is negative, we go down and to the right. We always move to the right. So from our y-intercept, we're going to move 2 up and 1 to the right, and that will place our dot. We can continue in this pattern so we can make sure we make a straight line. So again, 2 up, 1 to the right. 2 up, 1 to the right. There we have our straight line for the first equation. For the second equation, y equals negative 3x plus 3. Again, y is already by itself. And since it is in slope-intercept form, we can begin with our y-intercept. The y-intercept is 3. So we're going to begin by placing a dot on 0, 3. Now we can use our slope. Our slope is negative 3. Since it's negative, that means we have to go down and to the right. So we go 3 down and 1 to the right from our y-intercept. 1, 2, 3, over to the right. 1, 2, 3, and over to the right. 1, 2, 3, and over to the right. Now we draw a line. Wherever the two lines intersect, that is our point. Now, many times, the point of intersection will not be on a coordinate exactly. Okay, as you can see here. It fits in between perfect coordinates, but that is all right. As long as we have our lines perfectly drawn, we know the point of intersection is our solution. Okay, we have two equations here. Both of them already have y by itself. We have y equals 2x and y equals negative 6x plus 4. Since the slopes are different, we already know that these two equations should result in intersecting lines where there will be one solution. I'm going to start with y equals 2x first. Okay, so since we're starting with y equals 2x, if you notice, you don't see a b. If there is no b, you assume that the b is 0. So that means the first point we're going to graph is at 0, 0, which is right here at the point of origin. Our slope is 2. So that means that we have to go 2 up and 1 to the right. We go up because the 2 is positive. And we always go 2 up and turn it into a fraction. That means put the 2 over 1. So it's 2 up, 1 to the right. So again, I start my point, my y-intercept, go 2 up, 1 to the right. 2 up, 1 to the right. 2 up, 1 to the right. Again, drawing a series of dots so I know that my line is perfectly straight. My next line is y equals negative 6x plus 4. Again, we start with the y-intercept, which is positive 4. That means I graph my first dot at 0, 4. Now I start with my slope. My slope is a negative 6. Since it's negative, that's negative 6 over 1, which means 6 down and 1 to the right. So again, I start with my y-intercept and count 6 down and 1 to the right. Now, as you can see, I'm running out of room. I can't go 6 down and over 1 to the right. So I can go in the complete opposite direction, starting with my y-intercept. So I go back to my y-intercept. Instead of going 6 down and 1 to the right, I'm going to go 6 up and 1 to the left. So I stay on the same line. 1, 2, 6, and 1 to the left. Okay, I have my 3 points. And now I can draw a perfectly straight line. Again, where those lines intersect, that is your point, which is right here. So that is your solution. We have another system, y equals 3x plus 1 and x minus 3y equals 1. If you notice, the first equation is in the right format, y equals mx plus b. The second equation is in what we call standard form. We cannot graph an equation if it is in standard form, so we need to fix that. But let us first graph the first equation, y equals 3x plus 1. So our y-intercept is 1, so that means we graph at 0, 1. And our slope is 3. Since it's positive 3, that means 3 up and 1 to the right. So once again, we go to our y-intercept, go 3 up and 1 to the right, 3 up, 1 to the right. Again, you only need to make enough points so that you can guarantee a straight line. Now let's look at the second equation. To get in the right format, y must be by itself. So we don't need to move the y. We need to move the x. The x is positive, so to move it, we need to make it negative and move it to the other side. When we move x to the other side, we notice we cannot combine 1 minus x. 1 minus x cannot be combined because 1 is a variable and the other one is a constant. The x is a variable, 1 is a constant, so we cannot combine. So we're going to leave it alone. We have negative 3y equals negative x plus 1. Again, the y is not by itself. The negative 3 is multiplying the y, so we have to divide. Inverse operations. Remember that rule. So when we divide, negative 3 into negative 3 gives us 1. So we get 1y equals, negative 3 cannot divide evenly into 1x, negative 1x. But a negative divided by a negative becomes a positive. And again, negative 3 cannot go evenly into a positive 1. But a negative divided by a positive is a negative. So what we do is we leave everything as a fraction. So negative 1x divided by negative 3 becomes positive 1/3 x. Positive 1 divided by negative 3 becomes a negative 1/3 x. So now we have to graph this. Because these are fractions, our points are going to be estimates. Okay? So, our B is going to be 0, 1/3, and our slope, B is going to be 0, negative 1/3. Don't forget your signs. And our slope is a positive 1/3, so that means 1 up and 3 to the right. Okay? So, again, we start off with our y-intercept, 0, negative 1/3, which is right below 0. Then we go 1 up, so add 1 to 1/3, negative 1/3, which is 2/3, and 3 to the right, 1, 2, 3. And then we draw our line. Again, the point of intersection is our answer. Now, point of intersection is right here. Here we have a problem based on real life. You go into a photographer and he has 2 packages for sale. Package A is $25 for the first 12 photos and 40 cents for each extra print. Package B, you pay $30 for the first 12 and each additional print is 15 cents. So let's write some equations. For our first package, since 40 cents is for every extra print and X represents the number of pictures you have, we're going to do Y equals 0.40x plus 25, because $25 is the lowest price you're going to pay. So that's your initial value. Initial value or your starting point is always your y-intercept. So that means our y-intercept is 25, which means our point is 0.25, and our slope is 0.40. Now 0.40 means 40 over 100, which simplifies down to 2/5. So that means 2 up, 5 to the right. Package B starts at $30. So that is our initial value. So that's going to be our y-intercept. It's 15 cents per photo. So it's 0.15 times X. So now we start with our y-intercept. Y-intercept is 30. So we're going to start our graph at 0, 30. Our slope is 0.15. That means 15 hundredths. 15 hundredths simplifies down to 3 over 20. That means 3 up, 20 to the right. Since we are using such large numbers, such as 25, 30, 20 to the right, it makes sense to start our graph counting by twos and not by ones. If we counted by ones, we would need a much larger graph. So we're going to start by counting every unit by 2. 2 across, 2 up and down. So start with red, since that's how I did the first equation. My starting point is 0, 25. So I got to go 12 and a half units up since I'm counting by 2. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 25, right in the middle. Okay. From there, I'm going 2 up and 5 to the right. Since I'm counting by twos, 2 is represented by 1 space. So 1 space up and 5 to the right. 1, that's 2, 4, and 5. Okay, so now let's graph. So we're going to start with our red. Again, we're going to start at our y-intercept, which is 25. And since our slope is 2 up, 5 to the right, we go 2 units up and 5 over. Now remember, we're counting by twos. Since we now have 2 points, we're going to go to the next one. Again, we start at 0, 30 because that is our y-intercept. We're going to go 3 up and 20 to the right. So that's 1.5 spaces up and 10 spaces over, because again, we're counting by twos. We have our line, our points, 2 points per line. So we're going to draw. As you can see, it crosses where x is 20. Since x represents the number of photos, that means at 20 photos, both prices are the same. Which means if you order under 20 photos, you should use package A. It will be cheaper. But if you get more than 20 photos, which is this red line, which is this blue line here, once you get past 20, then blue, the second package, is actually cheaper. Here we have a word problem. Tickets for a concert cost $10 each if you order them online, but you must pay a service charge of $8 per order. The tickets are $12 each if you buy them at the door on the night of the concert. How many tickets must you buy for the cost to be the same? We will start with the online. Online is $10 for each ticket plus $8 service charge. So our equation will be y equals 10x, because it's $10 per ticket, plus 8 for the service charge. Again, that means our y-intercept is 8, which is 0, 8. And our slope is 10, which means 10 up, 1 to the right. At the door is $12, but no service fee. So that means y equals 12x. Again, since we don't have a b, b is 0. So we're going to start at 0, 0. And our slope is 12, which means 12 up, 1 to the right. So let me plot these points. I'm going to start with the first one in red. Again, I'm going to count by twos. 2, 2, 4, 6, 8. So I start at 0, 8, and I go 10 up. That means 5 units, since I'm counting by 2. 2, 4, 6, 8, 10, and 1 unit to the right. Since I'm counting by twos, that means it's going to go halfway. and I draw my line. Okay, my second equation starts at 0, 0. Again, I gotta go 12 up. So 2, 4, 6, 8, 10, 12, and 1 to the right. Again, that's about halfway. Okay, now I've got to find the point of intersection. With these, you have to be very careful of where your point of intersection is. Wherever it intersects, that is your point. Our focus question for today was, how can a graph help you find the solution of a system of linear equations? The graph of a system of linear equations will show you if the equations have one solution, many solutions, or no solutions. You need to interpret the result by identifying the point or points of intersection. Remember, one solution has one point of intersection, many solutions have all points in common, and no solutions will form two parallel lines. What's the solution of the system represented by the graph? Well, if you read the graph correctly, they're counting by ones. So this point is 1 to the left of the origin and 1 down. That's -1, -1. A GameSwap membership costs $20 and includes one game a month for $5. Non-members can get one game a month for $7. Explain how to use this information to decide whether to become a member. We write and graph equations for both. After 10 months, both cost $70. If you borrow games for more than 10 months, membership is cheaper. An error analysis. A friend uses a graph to compare her commute to school with yours. She says the point at which the two lines intersect is when you both arrive at school. Is she correct? Explain. The intersection is the point where we meet. She is correct only if we arrive at the same time.